Hello, welcome back to my channel JBTeguihanon, Engineering and Chemistry Tutorial. Let's continue our study, refrigeration system. Our topic for today is heat. This is just a review, quick review before we jump into the vapor standard vapor cycle or refrigeration cycles. So, heat, what is heat? Heat is defined as the energy transfer. So it is energy transfer, okay, transferred without transfer of mass across the boundary. So mass should not be necessarily be transferred, but uh, uh, okay, in the heat without the transfer of mass across the boundary uh, of the system because of the temperature difference. So temperature difference between the system and the surrounding. So it is usually expressed in Q, capital Q, and is expressed in joule. The unit is in joule or kilojoule. Okay, joule. So again, I will repeat now. So heat is defined as the energy transfer. Without transfer of mass across the boundary of the system, it is happening because of the temperature difference. Okay, this temperature difference sometimes most engineers use the word delta T. Okay, delta T or change of temperature or temperature difference. So that is the driver. That is the temperature difference between the system and the surrounding. Suppose you have a system, okay, I will find a space where I can. Suppose you have a system, and this is your system, okay, and this is your surrounding outside here. These are your surrounding, okay. So if your surrounding is greater, temperature of your surrounding temperature of your surrounding is greater than the temperature of the system, Ts, right? Then you have a transit energy, which is Q, that is coming in or crossing the boundary. The circle is your boundary, system boundary, SB. Okay, if this is happening. If the surrounding, the Ts, okay, is equal to the surrounding, sorry, environment, then there is no transfer of energy, Q. Q is zero. Okay, if they are equal means they are in thermal equilibrium. Q is 0. Means there is no transfer. Okay? So that is what it means, heat. So there are three mode of heat transfer. Okay, conduction, convection, radiation. So the transfer of heat through solids takes place by conduction, while the transfer of heat through fluids is by convection, and radiation is the electromagnetic wave phenomenon, okay, in which energy can be transported through a transparent substance and even through a vacuum. Can you see that? Even through a vacuum, Q is transferred by means of radiation. Okay? So these three modes of heat transfer are quite different, but they have one factor in common. What is that? What is that? Wait, I'm going to erase some figure here so you can see it clearly. So what is there? Common denominator is the difference of temperature of the systems and the surrounding. I have just explained that, right? Okay, so the following points are worth noting about heat. One, the heat is transferred across the boundary from a system at a higher temperature to a system at lower temperature by virtue of temperature difference. Number two, the heat is form of transit energy which can identified only across the boundary of a system. Okay, I want to erase some about the boundary of the system. It exists only during the transfer of energy into or out of the system. So it exists only during transfer of energy in or out of the system. So take note of that. It's just but at a moment. Number three, the heat flowing into a system is considered positive. So if this is your system, if the heat is coming into the system, that is positive. If out from the system, is negative. Q is negative. Here, positive. Okay, those are the things that we need to consider. Okay, so that's all for now. Please subscribe for those of you who have not yet subscribed. JB Teguihanon, Engineering and Chemistry Tutorial. Kindly hit the notification bell and please do like the videos. Thanks Bye. God bless.